So now that I've made my airplane, I've taped a quarter. Any coin will work to the front of the paper airplane. It makes it much more front heavy. The center of gravity is now way up here as opposed to back there where the middle where it was before. I'm going to throw it 5 times like this, measure how far it goes each time. Then I'm going to remove the quarter from the front, maybe carefully because I'm going to end up tearing my paper airplane and I don't want to do that. And I'm going to move it to the middle of my paper airplane. Yeah, I ended up tearing my paper airplane a little bit. That's not good. Okay. And I'm going to tape it back down to the middle of my paper airplane. I'm going to throw it 5 times with the quarter in the middle of the paper airplane for the middle of the center of gravity. Then I'm going to remove it again. And I'm going to put the quarter in the back of the paper airplane. And I'm going to throw it 5 times with the center of gravity at the back of the paper airplane. Okay? So that should give me 15 pieces of data that I'm going to graph. Well, I'm going to plot in the data table and then graph. I'll show you how to graph that in a second. So as you throw your paper airplane and measure how far it goes, you're going to plot your data in a data table. Your independent variable, in our case that's the center of gravity, goes on the left-hand side, and the dependent variable always goes on the right-hand side. It turns out, for those of you that are in algebra, you know when you're graphing in algebra, you've always got an X and a Y. This tells us that the center of gravity that's on the left-hand side always goes on the x-axis, and the numbers on the right-hand side always go on the y-axis. That's the one that's going up and down. So I totally just made up this data, so definitely don't copy this. I wasn't even very creative. I just numbered it 1 through 15. But if I threw it with the quarter at the front of the paper airplane and I threw it, it only went 1 meter, I'll write down 1. The next time I threw it, it went 2 meters. The next time I threw it, it went 3 meters. The next time I threw it, it went 4 meters, then 5 meters. This would be terrible data because it's not very consistent. Your data should be a lot more accurate than this. Then I moved the quarter to the middle and I threw it 5 times and just pretend these were my 5 pieces of data. And then when I put the quarter in the back, it was going a lot farther, 11, 12, 13, 14, and 15 pieces of data. Now before we can graph this data, once you have this data in the data table, we're going to find the average for each. So our graph is going to be a bar graph, and it's going to have 3 bars. One of them is going to be front, one's going to be middle, and one of them is going to be back. Now, I'm not sure if you learned this or not yet, but determining which type of graph you use is all based on what you have on the x-axis. So if you've got time on your x-axis, so if you're measuring things like seconds or minutes or days, you use a line graph. We've got the words front, middle, and back here, so those aren't dealing with time, so we're not going to use a line graph. If we've got names in the x-axis, we use a bar graph, and we've got names or words, front, middle, and back. So that tells us that the best graph for us to use is a bar graph. The most common graph used in science is a scatter plot, and a scatter plot is used if you've got numbers on the x-axis here that aren't time. We're going to graph the average data, so I don't want 15 bars on your graph. What I'm looking for is the average, and if you don't know how to find the average of data, what you do is you take your 5 front numbers, so I've got 5 of them, and I add them up. So if I add these up, it equals 15. Then I divide by however many numbers I've got. I've got 1, 2, 3, 4, 5 numbers. So the average for my graph here is going to be 3. My bar, when I go to graph it, counting by ones, for the front, it's going to be a bar that goes up 3 height. The middle, if I add these up, 10, 27, 40? Is that right? It doesn't seem right. 13 and 17 and 40, okay? Hope my math's right. Then divide it by 1, 2, 3, 4, 5. The average is 8. So this middle bar would have gone up to 8. Then for the back, we've got 50, 65. Divided by 5, that's 12. So this back one would go up to 12. Again, your data isn't going to be the same as this. I just want you to know what to expect, what I'm looking for when I see your graphs and when I see your data tables. Okay, so I showed you what the data would look like on the whiteboard. We actually need to draw one on our lab report. So to do that, we're going to go up to the Insert tab, open the Insert tab and go to Table. And it will allow you to draw what you want your table to look like. We've got 2 columns, and we've got 15 pieces of data. So I'm going to go all the way down to 15. Actually, I'm going down to 16 because we also need to put titles on our columns. So a 2x16 should work. I'm going to click on it, and it plops a data table into our lab report. Okay, so you can see that there. Now we need to title each column. So the x-axis, let's go ahead and bold this, was the center of gravity. And the y-axis, bold that, was the distance. And make sure you include the units. For me, it was meters. For you, it might be steps or yards or feet, whatever you figured out that you could use. I'm going to go ahead and highlight everything. I want all the data to be centered because I think it looks better that way. Okay, so the center of gravity, I had front 5 times. I have middle 5 times. Don't worry if it goes on to another page. Most lab reports, they've got pages and pages of data tables. For a really good lab experiment, you collect so much data, you might even collect 1,000 pieces of data. I don't want you to spend time collecting 1,000 pieces of data, but what am I doing? I don't want you collecting that much data. Ideally, you would if this was truly a professional lab report. More data, the better. But for time purposes, let's just stick with, and I believe I just did something lazy on mine. 9, 10, 11, 12, 13, 14, 15. Okay, and that's my data table. Don't put the numbers. Don't put 1 yard, 2 yards, 3 yards. I'll explain why. Because we're going to have another program make our graph for us, and the program will understand the numbers here if you put letters next to them as well. Okay, so our data table is done. Now we need to add a graph of the data below the data table. To do that, we need to open a different program in Google Docs. It's called a spreadsheet. And to open a spreadsheet, you go to the File menu on the upper left-hand corner, select New from the top of the menu, and drag down to the green spreadsheet icon and click on it. And a spreadsheet will open up for you. Okay. What we're going to do is we're going to put in column A and column B our summarized data. So we need to put the title in for our graph. So not the title of the graph. We need to put the title of the X and the Y axis labels on our graph. So our independent variable goes on the left. That was center of gravity. Notice I have it capitalized. Okay. And then in column B, I need to put distance, and then make sure you don't forget to put your units in there. In my case, it's meters. Yours might be steps or feet or yards or whatever you were measuring in. And then front, middle, spelling accounts, and back. And here, I'm not going to put all the data in. I'm just going to put those averages that we found, how I showed you how to find them on the whiteboard. So I had found mine was 3, 8, and 12. So that's all the data I need. You'll notice that behind you know, the number is kind of, the word gravity is hiding behind B. That doesn't matter. It doesn't make any difference. But if it bugs you, you can slide A out of the way. Just make sure you're writing everything on A and B and you don't skip to C. If you leave a gap in B, it'll mess up your graph. So to have it make a graph for us, we just highlight all the data that we want to graph. See how I've highlighted that in blue? And I'm going to go to this chart button and click Insert Chart. Alternatively, if you can't find this little chart button, you go to Insert, and there's a chart button in there, and you can click on it there. Okay, so it made a chart for us. It's got our title on it, distance versus center of gravity. So it's got both of our independent and dependent variables. It's labeled our independent and dependent variables on our X and Y axis. The problem is it made a line chart. And we don't want a line chart. We want this to be a bar graph. So I'm going to click on where it says line chart over here on chart type and select a column chart. Okay, so now my graph is all done. All I need to do is click on these three dots in the upper right hand corner, go down to copy chart, go back to my lab, and I'm going to hit on, mine's a PC, so it's Control V, or yeah, I think it's Control V. Nope. Edit paste. Yeah, paste it in there. And now I have my graph. I've made sure everything is capitalized. I made sure I've got my units of measurement on there. Everything looks great. Okay, so now I'm just going to go back and delete the notes that I left you. Again, it's talking about make sure things are capitalized and you got the units on there, everything I just told you, just as a reminder. So we're going to delete that, and now we've got our data table and our graph. Okay. Looks like I got a lot of extra space on this. I'm going to delete this extra space right now. And next up is the analysis. There we go. So for the analysis, this is the part of the experiment where we answer the testable question. And we're going to start our analysis with the data shows. And we're going to look at the graph to find out what the data shows. Now, according to my graph, having the center of gravity in the back causes the distance to be greater, and having it in the front is the worst. So the farther back it seems that we put the center of gravity, the farther the paper airplane flies. Now, your data is probably different. If your data has all the bars roughly the same, you're going to say that the center of gravity has no effect on the distance. If you've got, the middle is the highest, you'll say that the data shows having the center of gravity centered creates the greatest distance. Or if it's in the front, you'll say the front creates the greatest distance. So I got to write down what my data says. And so the data shows having the center of gravity in the back causes the greatest distance. Ways you can word that, that's just how I'm going to do it. And the analysis is done. Now I'm going to summarize my entire experiment. I'm going to delete the notes that I gave, just so it says a little more professional. I'm going to have at least 5 sentences in my conclusion that summarize the entire experiment. So I'm going to start off with number 1, what I've got there, which says restate the hypothesis. So I'm going to start typing the hypothesis was, and my hypothesis, as I recall, was that, I don't have it up there anymore, I deleted it, was that having the center of gravity in the middle would cause the paper airplane spelling to fly the farthest or furthest? Furthest, I believe. Furthest. Okay. Fly the further? No. See, and it underlined it because it says that's bad. So hit undo. What? No, not furthered. Cause the paper airplane to fly the farthest. It says it likes that. My next sentence is going to be if the hypothesis was true or false. make this a complete sentence. So don't just say true. I'm going to say or false. In my case, the hypothesis was false. The hypothesis was false. Again, it underlined because it says I misspelled something and it suggests that I fix it, and I will. Okay, right here it says for sentence number 3, restate the analysis. Okay, so I'm going to rewrite the analysis. An extra capital. The data shows having the center of gravity in the back causes the greatest distance. Trouble typing. Then the hardest part is, why did the results turn out the way they did? Now, if I was right, I could go back up to my hypothesis and remember where I said because, and I was talking about aerodynamics and whatnot. Well, I've proven that that's not true. So I need to come up with a new because statement. So why do I think that the airplane, what would possibly cause having weight in the back make the airplane fly farther? I'm going to just see why I think that what might happen. I'm going to say the results turned out this way because the weight caused the nose of the plane to point up, which made the plane stay in the air longer. Now that may or may not be true. Your new because statement doesn't have to be true. It just has to be your new best guess. So the last thing we need to include is step 5 here, discuss possible errors in the experiment or how the experiment could be improved. Basically what you want to do here is discuss how any difficulties you had, like keeping the control variables. So maybe you had trouble, throwing the paper airplane outside and the wind kept blowing and was messing up your data. Or maybe you kept throwing it and it kept turning and running into a tree. One thing that really stands out to me is that we only collected 15 pieces of data. And so in general, for most experiments that you don't spend weeks on collecting data, you probably haven't collected enough. So I'm going to choose that as the way that my experiment can be improved. The experiment could be improved by collecting more data and getting more reliable results. And now my lab report is done. And so I'm going to go ahead and delete these notes that I just had you fill in for each of those 5 sentences. Double check, look over everything. It looks, well, I deleted all that stuff on the front, but everything is included in there. If everything is good, go ahead and submit it to me and I'll get it graded for you.